Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series today, we're going to see about the basic operational concept in computer architecture. So majorly in my previous video, I have explained about what is the computer architecture and how it can be works and what are the basic thing is available in the computer architecture that we have discussed in my previous video. So in this video we're going to see how the basic operation can be executed in an architecture. Before going to that, we have to analyze how the processor and memory are connected, because this both the thing is one of the storage place for storing the data. Processor also, it will have a register. So while processing any data, all our data can be moved from memory to the processor. Once the operation is completed, again it can be write back the data to the memory. So this both the thing are interconnected while executing an instruction. So it will have a various function. First one is a program counter. So program counter always contain the memory. It loads it holds only the memory addresses. So what type of memory address can be stored over there is the next instruction. What is the next instruction to be fetched from for the execution of an instruction? In that case, we are using a program counter. Simply we can say it contains the memory address of the next instruction to be fetched. So the next type of a register is an instruction register. It holds the currently executed instruction. It always closes the currently executed instruction. Other than this thing, we are having a two more register or there in the processor. One is the memory data register, another one is a memory address register. Since both this can be used for communication with the memory only we are using. So your MDR can contain the data to be written into a read or a write of the addressed location. So we can clearly say that our MDR register can contain the address location of that particular data. So that holds it in the MDR, that is a memory data register. So your address register, what type of a data you're using is in MDR. So we know the address of that particular data, where I have to access the data, that to be available in the memory address register. Usually you are having a general purpose register that is started from R0 to Rn. It is based on the processor. If I'm having a 32-bit processor, it will be started from R0 to R31. If it is a 64-bit, R0 to R63. These are the general purpose register for performing an operation. So according to the conclusion, we have in a processor, we are having a 4 different type of a register can be used. One is a program counter, instruction register, memory data register, and memory address register. The next thing is this is a basic diagram how a memory and processor are interconnected, because through system bus only all our units are connected each other. This is a MAR. MAR can contain the program counter and instruction register. MDR can contain the general purpose register. Both the data will be sent to the ALU unit to perform a arithmetic and logical operation. Everything is controlled by the control unit. Through system bus, the information can be passed between the memory and the processor. Initially, our data will be flowed to program counter. After it will be moved to IR register. Through IR, it identify what is the data and equation. That particular location data will be moved to the ALU unit. So in this case, MAR can contain the M-bit address mode, means MDR can contain N-bit data bus. So how many memory locations are there means total number of address location can be calculated as 2 to the power of M. Here word length, number of bits can be called it as a word length, and capacity can be calculated as a 2 to the power of M into N divided by 8. 8 is the 8-bit, that for that only we can call it as a 1 byte. So for conversion onto a byte only we are dividing by 8. So your capacity is for M bit of address location, we can calculate it as 2 to the power of M into N divided by 8 bytes. So this is the operation and operands. For operation and operation, we are having a two types of a number. One is a signed number, another one is a unsigned number. Unsigned number is only a positive number. Signed number is both positive and the negative number. These are the representation of a number. So while doing a basic operation, an instruction can contain both operation and operands. According to assembly language, our operation can be written in terms of opcode. All our variable we can able to represent in a operands. So these are the example of the operation. While adding a two thing, I can use the two different type of a register. Either it can be a memory location or a register. So this type of address we can call it as a two address format. This also two address format. This also two address format. Then these two cases is related to the memory. First, we have to memory data can be loaded to the R0. Here, memory location data can be loaded to R1. After it will perform an addition operation. So both the thing is same, but here we can directly perform an addition. Here, first we have to load the data from memory. After that, we can perform the address. So this is the how a basic operation can be taken place. For example, if I want to add a 4 variable. So simply in our high level language, I can able to see A equal to B plus C plus D. A plus B plus C plus D plus E. Similar way I can able to work it out. But here I have to use the only either I have to use two operands or a three operands or a single operand or a zero operand representation. I can able to perform an addition operation. First I have to add the two numbers so that I can store it the value in A. And again, I can go for the continuously. My final previous intermediate data is available in A. Through that, I can add the one more new number that will be stored it in the same A. Again, my three of my data is available in A. Though through that, I can add the another variable value A, comma E. So that is also stored over here. This is the how a addition of 4 variable can be taken place in the assembly language. So these both the thing are the address format. So in this cases, we can able to represent the instruction format in either R type, I type and J type. R type is all arithmetic and logical operation will come under the R type. I type it will have only load and store operation. Jump is nothing but your branch instruction. So this is the how whatever the operation we are performing. So again, it will be converted into a binary, can be converted in the hexadecimal, then only it can be stored in our processor. This is the how it can be work. So these are the various assembly language operations are available in the MIPS instruction sets. So that's all about the basic operational concept. In my next video, I'm going to detailedly explain about the bus stitcher. Thank you for watching my video.